Good evening, everyone. Today we will go to start the new chapter. This is the solution chapter for class 12, and today is the first class of solution chapter. So basically, we will know about the solubility of solid in solution and also the solubility of gas in liquid. So in the solution chapter, first we will know about what is the basically solution, what is the mean of the term this is the solution. So if I say that I have a water, a glass of water, okay, so it is not a solution, it is not a solution. Okay, if I add something, suppose I have adding, I am adding the sugar, some amount of sugar I have added, uh, and this is the water. Then this sugar will be soluble in water and it will make a solution. So solution means there are the two things. One would be solute, another would be solvent. In this example, the solute is sugar, and the solvent means, so water and the sugar mixed up and it is going to term as a solution. So solution means there are the two things. One is the solute, another is the basically the solute. We know that the solute means it is solid, and solvent means we know that it is the liquid. We know that every matter has the three state. One is the solid, second is the liquid. So we know these are the three known states of a matter. uh, they can exist as a solid. Suppose ice ice can exist as a solid, it can exist as a water, that is a liquid, and it can also exist as a vapor. So it has the three state. So if I say that when the solid the solute is a solid and the solvent is liquid, then we will say solubility of solid in liquid. Okay, when it is gas but it is liquid, then we will say solubility of gas. So we will know about these two category of solubility. There are the various type of there are various number of solubility category, like when it will be the liquid, it will be the liquid. When it is gas, it is the liquid, solid gas. So there are the various type of the combination could be possible between the solute and the solvent. So there is the lots of possibility. We can change the solute, we can change also the solvent uh, as the state, as a state. Okay, when it is the solute, when the solvent is the liquid, then we will say it is a solubility of solid in liquid. When the solid is the gas but solvent is the liquid, then we will say it is the solubility of gas in liquid. So there is the number of combination is possible, but in this chapter we will know about the two possibility. One is when the solid is the solid and solvent is the liquid, and solid is the gas and solvent is the liquid. So these two possibility we will know. Before that we will know about the solubility. What is the solubility? Okay, So the solubility means a substance. So what is the solubility? This is the very important thing. It is means that when a substance in its the maximum amount that can be dissolved in a specified amount of a solvent at a specified temperature. What is mean? Suppose I have a solute A, and I have a solvent. It is a liquid. It is a liquid. Uh, it is a B, and a specific temperature. The temperature is fixed. The specific temperature is fixed. It is suppose the T. Okay. So in this specific temperature, okay, in this specific temperature, how much maximum amount, okay, maximum amount, when the maximum amount of the solute A is dissolved in solvent B, that is called the solubility. Suppose the temperature is 300 Kelvin. Okay, suppose the uh, okay, suppose the temperature is 298 Kelvin. Okay, so there is a glass of water. So this is the water level. I have added, first I have added 1 gram sugar. It is soluble. 2 grams sugar. It is also soluble. Then 3 grams sugar I also added. It is also soluble. But when after 3 gram, when I have added the 4 gram sugar, it is not soluble. Some amount of the sugar is not soluble in this water. That means that maximum amount of the sugar is the 3 point something. It will be not the 4. Okay, so when we will say solubility means maximum amount of solid is the soluble in solvent at a particular specific temperature. Temperature will be the specified always. So then we can say it is a solubility. But there is some factor. There is some factor is that if I say some example, that suppose sugar or NaCl, suppose the NaCl, okay, it is soluble in water, readily soluble in water. NaCl is readily soluble in water. There is no problem. It 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 is soluble in water. But if I say naphthalene, if I say naphthalene or anthracene, these are not soluble in water. They are soluble in benzene. So there is a factor here. Temperature is fixed. Temperature is fixed. Whatever temperature I have given here, suppose 298 Kelvin. Here I also given the 298 Kelvin. The temperature is fixed. But solute and the solvent are the different. In this case, NaCl is solute and water is a solvent. In this case, naphthalene and anthracenes are the solute and benzenes are solvent. When we are trying to dissolve in water, it is not going to soluble. Why? Because there is another factor, that is the polarity. That is the polarity. It is the most important thing, the most important points for the soluble, for the solubility, is that more polar is that more polar solutes are soluble in more polar solvent. Similarly, less polar solute are soluble in less polar solvent. So this is the rule that for the polarity, whatever molecules is there, we have to see which molecules are, which solute are the polarity. They are the polarity which is the more polar. That means it will be the more soluble in more polar solvent, which is the less polar, that will be the soluble in the less polar solvent. Okay, like that. Here, anthracene and the naphthalene, this type of the molecules are the less polar. That's why this type of the molecules are soluble in less polar solvent. Benzene is the less polar solvent because we know that its dipole moment is the 0. So similarly, if I draw the anthracene like that, so these molecules also have the less polarity. Polarity is a very less, so it is soluble in less polar solvent. This is the benzene. But in case of NaCl and the water, NaCl as a actually cation and anion, Na plus Cl minus ion. This is the ionic species, so it is the more polar. So water also the polar solvent. Okay, water also the polar solvent. So that's why NaCl is soluble in more polar solvent, but anthracene and the naphthalene, these are the less polar solute. So these are the soluble in the less polar solvent. So these are the case. Now, when we are going to discuss about solubility of solid in a liquid, we are going to discuss about, now we are going to discuss about solubility of solid in liquid. What it means? That means that here the solid is the solute and liquid is the solvent. So there are the some terms when it is happening, like if I say there is the some term like this solution term, second is the crystallization. So this type of the two processes, so these are the two processes actually happening when a solid particle, a solid particle going to dissolve in a liquid. What is that? If I say that, suppose suppose for example, I am adding NaCl, sodium chloride, in water. Okay, so what will be happened? First, what will be happened is there Na plus Cl minus, so it has a Na plus Cl minus as a cationic and the anionic form is there. When I am adding the NaCl, then the NaCl will be dissolved in water. That will be the dissolves in water. Water is a solvent. When there is no NaCl is there in water, so there is concentration of the solvent is 0. But when we are adding the NaCl and NaCl is going to dissolve in water, then the concentration of the solution is increasing. Okay, so that is called dissolution. Dissolution process means when say solute is added to the solvent, some solute dissolves and its concentration increases in solution. Okay, so when are adding the NaCl in water, that means it is creating a solution. There is no solute, there is no solvent. It is a mixture of the solid and mixture of the solvent. So we can say it is a solution. Okay, so this process is known as the dissolution. So the dissolutions means the NaCl is dissolving. So there is one process is happening. This is the dissolution, where NaCl is dissolves in water and its concentration increased. So this is a process that is called dissolution. That is called dissolution. Another process could be happened. What another process could be happened? This process is called crystallization. What is that? When this process will be happened? When suppose like that, I have added the 4 gram NaCl. Okay, 4 gram NaCl is continuing dissolving. Okay, continuing dissolving, and it is forming a dissolution. But with simultaneously some solute, some NaCl is connecting to the another NaCl, and it is formed the crystal. That is called the crystallization process. Okay, so crystallization process means when we are trying to dissolve a solute part, a solute in its corresponding the solvent, some amount of the solute will be the dissolved in the solvent. Okay, but some amount of the solute part as a solid, it will interact with this another solid, and it will form a crystal. That is called the crystallization process. So we will see that when some laboratory, when they want to make a crystal of some inorganic materials, some organic materials, first criteria will be that the solubility. So the solid part should be soluble in the solvent, but during solubility, some amount of the solute part will interact with this another solute part, and they will make together form the crystal. That is called the crystallization process. So that is called the crystallization process. So these are the two process is happening: a dissolution process and a crystallization process. Under such condition, the number of the solute particles going into the solution will be equal to solute particle the separating out, and a state of dynamic equilibrium is reached. What is mean? Some solute particle, when we are adding the NaCl, the some solute particles is going to the dissolution process, some solute particle is going to the crystallization process. When this process will be a dynamic equilibrium will be formed, when there will be the equilibrium between the two processes, one is the dissolution, another is the crystallization, then we can say it is a saturated solution. Then we can say it is a saturated solution. So there will be, so for the saturated solution, there will be a equilibrium of dissolutions, uh, dissolutions and crystallization. So in this equilibrium, solute plus solvent is equilibrium to solution. So what is the saturated solution? Saturated solutions means there will be equilibriums between the dissolution process and the crystallization process. That means that whatever amount we have adding the NaCl in the water, that will be totally dissolved. Okay, that will be totally dissolved. That is called the saturated solution. When we are adding excess amount of NaCl in water, then some amount of the NaCl is not dissolved. It is act as a it is there act as a precipitate. Then we can say it is a unsaturated solution. It is a unsaturated solution. So saturated solutions means in a water some amount of the solvent you have given. Okay, so in this solvent you have to know how much amount of the NaCls will be the dissolved. Suppose the 5 gram NaCls will be the dissolved. So 5 gram, when we are adding the 5 gram NaCls, so it will be the dissolved. When we are adding the 0.1 gram excess, then it will be not dissolved. So up to 5 gram is the maximum amount of the NaCl that will make a saturated solutions with the water, not 5.1. When we are adding the excess, then it will make a unsaturated solution. So these are the solubility of the solid in a liquid. This type of two process are generally happened in when we are going to dissolve of a solid in a liquid solvent. There is two process. One is the dissolution, another is the crystallization process. For a saturated solution, there will be the equilibrium. But everything, whatever we have discussed here, the everything is at the specific temperature and the specific pressure, at a constant temperature, at a constant pressure. But what about the when we are we increasing the temperature, suppose the lowering the temperature, increasing the pressure, lowering the pressure, what will be the effect of the solubility? So now we will know about the effect of temperature. For that case, the solubility of solid in liquid, the effect of solubility of a solid in a liquid is significantly affected by temperature changes. Consider the equilibrium represented by whatever equilibrium is there, that is the solid plus solvent, it is equilibrium to solution. Okay, so this being the dynamic equilibrium, and this equilibrium will follow one rule that is called L'Atelier principle. So in this principle, what they have said that if that dissolution process, when this process is endothermic. Endothermic means delta A is greater than 0. Okay, then with increasing the temperature, the solubility also increased. But when this process is exothermic, that means delta A is less than 0. If I temperature the increased, then solubility will be the decrease. Because suppose a dissolution process is happening the endothermic. Endothermic means delta A is greater than 0. It will take the temperature to do this process. Okay, so to happen this process, we need a temperature. That's why it is an endothermic process. That's why when the temperature is increased, the solubility should be the increase. When a dissolution process is exothermic means we need no temperature outside the environment, from the outside. Here, when the solubility process, this dissolution process is happening, then some amount of the temperature is formed from the system. That's why the delta H is less than 0. Okay, so in this case, if I increasing the temperature, solubility will be the decrease, because the solubility, because in this case, when the solubility is happening, then some amount of the heat is increasing. Sorry, the some amount of heat is formed from the system. That means that we do not need any temperature to soluble. So these are the two process. These are the two effect of the temperature. But if I say about the effect of pressure, so there will be the no effect actually, because effect of pressure will be effect on the solubility of a gas in liquid. When we are talking about the solubility of the solid in a liquid, so there will be the no effect of pressure. Okay, so there will be the no effect. Next, we will discuss about solubility of gas in a, here what is gas is liquid is solvent. Okay, so that means that is the liquid. In this liquid, we want to dissolve gas. That is the solubility of the gas in a liquid. So there is some example. If I say oxygen dissolves only to a small extent in water. That's why the fish, like the fish, or there are the many aquatic lives are the alive still now, because some amount of the oxygen is the dissolves into water. That's why from this water they have taking the oxygen. Or we can say another example that uh, hydrogen chloride gas, HCl gas, it is a highly soluble in water. So there is a possibility. So there is no not like that it is not possible solubility of the gas in liquid. There is a possibility. There is the example in a nature our in our nature that soluble of the gas in liquid. But there is some effect of temperature and also pressure. What will be the effect? That is the main point. Solubility of the gas increases with the increase of pressure. If I talked about the temperature, there is not too much effect on the solubility of gas in a liquid, but there is most effect, there is the important effect of the pressure, the effect of pressure. That is the most important for that solubility case of gas in a liquid. It is saying that the solubility of gases increases with the increase of the pressure. For a solution, suppose a solution, so what is statement is there, solubility is increasing, solubility is increasing with the pressure. When we are increasing the pressure, then solubility of the gas in a liquid, it also increased. Let us assumption that, suppose there is a assumption, this is a liquid part, there is some amount of gaseous particle, there is some amount of the gaseous particle, and there is a piston above the solid, and this is a W1, one piston is there, but another container is there, another container where we have created a pressure 3 times. Okay, 3 times we are creating air pressure 3 times. So then what will be happened? Whatever gaseous molecules is there, this will be the soluble. Okay, so what is happening here? With increasing the pressure on the liquid, the solubility of the gas in the liquid is increasing. So this is the effect of a pressure. So here, from that here, the Henry's law that came. Henry's law state that the solubility of a gas in a liquid is directly proportional to the partial pressure of gas present above the surface of the liquid or solution. What is mean that? So we can say from that the solubility is, we can say the solubility proportional to pressure. But from the Henry's law say that the solubility of a gas in a liquid is directly, so solubility is directly proportional to partial pressure of the gas, which are present above the surface of the liquid. That means what is happening here? What is happening here? Okay, so to know the law, we have just creating here. So this is the liquid part. Okay, that is the liquid part. I have, here is a piston. Suppose here, so there is a gaseous molecule. There are some gaseous molecule is there. There are also some gaseous molecule which are the soluble. Okay, but now I am creating a pressure from the outside. So when I am giving the pressure on the piston, what will be happened? These gaseous molecules, the large number of the gaseous molecules will be soluble. The large number of the gaseous molecules will be soluble in the liquid. Okay, so that means that we are creating a pressure on the gaseous molecule. So, so these gaseous molecules is going to solubles in the solvent. That means that these gaseous molecules also creating a pressure on the surface of the solvent. That's why they are going to the soluble. So we are creating a pressure from the outside on the piston, but this pressure we are creating on the gaseous molecule, and these gaseous molecules also creating a pressure on the solid surface. Okay, so this pressure actually this is the this partial pressure, this partial pressure of gaseous molecule is affected, is effective to soluble. This pressure is not effective. Okay, this pressure is not effective, just we are forcing. But effective pressure is that the partial pressure of the solid, the partial pressure of the gas, that is the effective. That's why the solubility is proportional to partial pressure of the gas which are the present on the surface of the liquid or the solution. So this is the actually Henry's law, where we can say that the solubility is proportional to the partial pressure of the gas. If I represent the partial pressure, the partial pressure means there is whatever gaseous molecules who are there, then the partial pressure will be the increased. Suppose there are the 5 gaseous molecule, and another container there is the 10 gaseous molecule. So where the 10 gaseous molecules, their partial pressure will be the high than the 5 gaseous molecule. So we can consider, we can say that this partial gas, also we can say the mole fraction of the gaseous molecule. Okay, because the partial pressure is proportional to the number of gas. Then number of gas we can say as a. So from that we can say the mole fraction of a gas in solution is proportional to the partial pressure of the gas over the solution. So mole fraction, if I consider the mole fraction is the x, then partial pressure P is proportional to the x, then partial pressure P is समान KH into x. Okay, so this KH is called Henry's constant. This is the Henry's constant, and that is called the Henry's law, and this is the Henry's law. So this is called the Henry's law, and this is called the Henry's constant, where we can say the partial pressure of the gas is proportional to the partial pressure of the mole fraction of the gas. The most commonly used form of the Henry's law state that the partial pressure of a gas in a vapor phase, that is called the P, partial pressure is proportional to the mole fraction of the gas, that is called the X in the solution. So if I draw a curve here, I will stop here my today's class with this slide, that so we have known that the Henry's law is partial pressure P equal to KH into X. So if I compare with this equation with the straight line equation y equal to mx plus c, where c is the 0, and m is equal to the KH. So suppose it is the partial pressure, this axis, and in this axis is the mole fraction. So there is the no component, so the curve will be like that. Sorry, the curve will be like that. Okay, where the m equal to kh. So there are the another statement is that there is the another statement where we can say that like partial pressure P equal to kh into x. So kh equal to partial pressure by x. If I consider partial pressure is constant, then kh has 1 by x. Okay, now, so what is statement that when the kh value is increasing, the mole fraction of the gaseous molecule is decreasing, and we know that p x p, this is the partial pressure, is proportional to the x. That means it is proportional to the solubility. So kh has 1 by. That means when we will say, suppose nitrogen, for that nitrogen gas kh value is 88.84, but for the oxygen gas kh value is 46.82. Okay, so where the kh value is high, that means solubility is less. So here the nitrogen solubility is very less, but where the kh value is very low, there is solubility is high. Because we know that k is the Henry's constant, it is actually specific for another gas. For a particular gas, it will have a particular value, and from that value we can say that it is the highly soluble or it is the less soluble. When the kh value is the high, then it will be the less soluble. When kh value is the less, it will be the highly soluble. And there is also effect of the temperature. It is saying that the temperature, the T, varies as 1 by x. When we will increase the temperature, that is the effect of the temperature. Okay, whatever we have seen till now, that is the effect of the pressure. Now we are discussing about the effect of the temperature. When we will increase the temperature, then solubility will be decreased, because 1 by x, that means the solubility, because the mole fraction is proportional to the partial pressure proportional to the solubility. So temperature, when we will increase the temperature, then solubility is decreased. Then now 1 by solubility is proportional to the k of h. Now the k of h is equal to T. So when we will see that the temperature is increasing, suppose there is some gases there which have the higher kh value, it is a constant value. So this is the Henry's constant. So higher kh means the solubility is decreasing. That means the temperature will be high, because with this solubility the temperature is the not proportional, it is the disproportional in relation. So till now we have discussed about the solubility of solid in liquid and solubility of gas in liquid, and there are the two effects of the temperature and also the pressure. And here we have discussed about the last layer's principle, which is the effect of the temperature for that solubility of the solid in liquid. Then we have discussed about the Henry's law, which is the corresponding to the solubility of the gas in liquid. Then they have the some effect of also the temperature. So in the next class we will discuss about some MCQ question, whatever I have discussed here. Based on that, I will discuss about the MCQ question, then discuss about the another topic. Thank you guys.